I have a triangle here where I know an angle and I know two sides, and I'm being asked to find a third, and I have not been given a right angle. So I can't use basic SOHCAHTOA on this because it's not a right angle triangle. But never fear, that doesn't mean it's unsolvable. It just needs a more complicated tool. So we're going to have to use cosine law. So if you sort of ignore this part, you get a squared plus b squared equals c squared. That's Pythagorean theorem. With a tiny little correction on there in case you don't have a 90-degree corner. So how do you use this? Well, you've got to identify which pieces go where first. So the trick is that if this is the angle you're using, the side that goes with it is way over here. They don't touch each other. And you've got kind of a clue in the equation up here. The angle that you're given and the side across from it are literally on opposite ends of this equation. So I'm going to use this as phi. That's this thing here. That goes here because it's the angle or the side across from the angle I'm going to use. And these two sides are interchangeable as A and B. So if I fill in this formula with those symbols, I'll have m squared is, I'll use 11 for A, and I'll use 9 for B. A was 11, B was 9, and I've got cos 36 degrees. Okay, so you've got a whole bunch of numbers there and a whole bunch of work to do with order of operations. So I see an 11 squared here with some adding. The square is going to take precedence over the adding, so I'll do it first. 11 times 11 is 121. 9 squared is 81. And I have some subtractions and multiplications here, so I'm going to do the multiplications first. 2 times 11 is 22. And I have a cos 36 here that I can do. Calculator. Cosine 36. 0.809. Okay. So that's not everything I could have done in one line. I just sort of went through and did some steps. You could see how this is going. There's no multiplication happening with these numbers anymore, so I'm free to add them. 121 and 81 would be 202. I've got a 22 times 9 that I could do. Is 198. I'm still going to need to do this multiplication before I can do that subtraction. 198 times 0.809 is 160.182. And 202, subtract that number, gives me 41.818. Last thing to do, I just need to break that square. Now, I'm going to write this in to be technically correct, and then we'll discuss. Anytime you use a square root to break a square, you need to consider both the plus and the minus options. So m is plus or minus square root, that's a cube root, square root of 41.818, square root of 41.18, 6.47. Okay. So if you've got all the numbers and you just have them on this side, you just have to slowly work your way through the order of operations. And because I do technically need plus or minus anytime I break a square with the square root, I end up with the answer plus or minus 6.47. Now, in the context of a geometry problem, the length of this side can't be negative, right? Negatives aren't allowed for lengths. That doesn't make any sense. So in this particular question, because of context, the length of that side is going to be positive 6.47 units. We have another example here. This time, I have lengths for all three sides, and it's the angle that I'm missing. So the angle is going to go there, obviously. Whatever number, whatever the side length, is not touching the angle in question is the one that goes over here. So if I look across that triangle, I see the 15 is here. So the 15 is going to be my C value, because they are on opposite sides of the triangle, opposite sides of the equation. A and B are really interchangeable, so I'm just going to make 10A and 7B. So I'm going to have to fill in this equation. So 15 squared is 10 squared minus, plus 7 squared minus 2 times 10 times 7 times the cosine of an unknown angle. All right, 15 squared is 225. 10 squared is 100. 7 squared is 49. 2 times 10 is 20. I can do 100 plus 49, that's 149. 20 times 7 is 140. All right, and normally I would just carry on with the correct steps, but I need to point out to you that this thing is a number, and this thing is a number with a letter attached to it. So what you're looking at there is like something like this. A number on its own, and a number with a variable attached to it. But when you see this, you are not allowed to combine those, because this isn't worth 140. It's worth 140 multiplied by some other number that I don't know yet. So it's a very common error to look at this type of thing and say, oh, well, that must be 9x. Well, it is not that. Don't do that. This is a number with no x's at all. So you can't just vanish it and say there's 9 x's left. There's 140 x's and some number that doesn't have anything to do with x. So please don't squash them together like that. So if I'm not allowed to do that, I can't combine these two things because this has a variable and this does not, then I've flipped into algebra at this point. I have to start moving things to the other side. So if I knew that, I would cosine it, then I'd multiply it, then I'd subtract it from this number. So that's the one I have to move first, because it would be the last thing in the order of operations. I'm going to subtract this from both sides. And 225 minus 149 should be 76. I'm just going to check that. Okay. And to finish, I need to divide both sides by this negative 140. And I get 0.543. All right. So I need to arc coast that. And I get 122.87 degrees. Okay. So after doing all that, it's a good idea to sort of check your work. This is going to be the biggest angle in this particular triangle because the triangle's angles have to add up to 180. So there's only like 57 degrees left to spread up between the other two. So this has got to be the biggest one. And the biggest angle has to be across from the largest side. Like by definition, you can't make this really wide and have the side it generates be very small. So it's impossible. So in this particular case, the biggest angle is going to be across from the biggest side. So it all worked out. Now, technically here, this is like the plus or minus thing on the square root in the last example. Technically, anytime you pull arc cos, you get two answers. So if I just quick sketch that up there, and you're gonna take a deep breath and not panic. Cosine waves look like this. I had a cosine that was negative, so the negatives are down here. So I've got one solution there, one solution there. So I need a number between 90, where cosine hits the x-axis, and 180, where it hits its trough. And I need a solution somewhere between 180 and 270, which is where cosine comes back to the x-axis. So I look at this number here, I have 122.87. That's right in this range there. So I've got this solution, the descending one. I need the ascending solution. And if you go back to the trigonometry for obtuse angles step, see that that distance and that distance are the same by symmetry. So my second solution would be 360 all the way to the end, and then back up this much. So 360 subtract 122.87 is 237.13. Now that's impossible. Because the angles in a triangle are supposed to add up to 180, and this has blown past that by almost 60 degrees. So having done all this work and then covered the technicality that this thing could have two solutions, we've settled on that angle must be 122.87. Now this thing, if you notice, your solutions are either, if you're trying to do a triangle, your first solution is going to land either on this curve here, or it's going to end up there, because those are where the angles up to 180 are. And those are the only angles that are allowed in a triangle. Your second solutions for cosine fall over the 180 mark, right? They're all on this arc. So every other second solution to a cosine problem is going to end up giving you an angle that's too large anyway. So this, you don't actually need to do this. I just put it in for completion so that we can keep that in mind when we get to sine law. Because when sine law comes along, this will matter. So a third example here. This time I have the angle. I have the side directly across from the angle, so I know what to put in for C. I know one of these letters, which I can put in for A, and then I have this B kicking around, which is going to fill in for my other missing side. So I just got to get all that stuff in there. So just one more time. Here's the angle. Look across for the side that doesn't touch it. That's going to be your C. So I fill this stuff in. I'm going to have 10 squared is A squared plus B squared. And it's going to stay B because I don't know that side yet. Minus 2 times the A value times B times the cosine of the angle in question. Okay, so 10 squared is 100. 4 squared is 16. B squared is just a B squared. 2 times 4 is 8. And cos 65 is 0.423. Another line here. 100 is 16 plus B squared. 8 times 0.423 is 3.81. 3.381 with a B still attached. And then we're going to scratch our heads a little bit because this is a touch problematic. I have a B squared and a B in my equation here. That means it's a quadratic. That's the thing where if you sketch it, it makes a parabola. So you can't just use linear algebra on quadratics because they're nonlinear equations, right? They have a variable and that same variable squared. So we need a trick to work this out. Quadratics go with the quadratic formula. If you remember from grade 10, the solution would be plus or minus B minus, no it's not, minus B plus or minus the square root of B squared minus 4AC all over 2A. Yikes. I have to get this bent into that formula. So this particular thing works if you have, maybe I'll put these in capitals because there's some lowercase b's over there. There, problem solved. This thing works if you have an equation shaped like this. So everything has to be pushed over to one side. It has to be equal to 0. So I'm going to do that here. I'm going to pull this 100 over so that there's nothing left on that side. 16 plus b squared minus 3.38b subtract 100. Now to get it to look like this, I need to find the variable squared. That's here. I'm going to write it first. And then I need to find the thing with the variable not squared. That's here. Write it second. And then 16 minus 100, those are just numbers with no letters attached, so I can combine them. 16 subtract 100 would be negative 84. So I have this thing in that format, which means I can use my quadratic formula now, putting in a 1 for the a value, negative 3.38 for the b value, and negative 84 for the c. I'm going to try and do that down here. I think I'm going to run out of space real soon. So this thing, the value of the variable, in this case it's b. b is negative 3.38 plus or minus the square root negative 3.38 squared minus 4 times 1 times this over 2 times this. All right, negative 3.38 is just 3.38. 3.38 squared gives me 11.431. 4 times 1 times 84 gives me 336, and a negative times a negative is a positive. Goodness, this is a lot. Okay, I'm going to erase this so I have some room here. So I have b is 3.38 plus or minus the square root of 336 plus 11.431. That will be 347.431. All over 2. To do this square root of 347.431 gives me 18.64. So here I've got two cases. One where it's 3.38 plus 18.64, and one where it's written on my forehead, 3.38 subtract 18.64. Okay, this one here, 3.38 plus 18.64 gives me 22.02 if I round it. So B is 11.01. So that side has to be 11.01 long in order for this triangle to work out. Now this option here, if I do 3.38 subtract 18.64, I get negative 15.26. Let me shuffle here so it's out of my face. Over 2, which means I've got negative 7.63. So, I mean, technically that's an answer. It did come out of all the algebra stuff, but a triangle can't have a negative side length. So by context, that solution isn't an option. Now, you might be looking at that and you might be saying, goodness, that was a lot of work to do to find that one side. I had to use quadratic formula. You're right, that was a lot of work. In a triangle like this, it's likely that you would be able to use the other trig law that you know, the sine law, in order to find this angle here, and then use sine law to find that side. That would be a lot simpler than quadratic formula. But you have to choose that. So if, for some reason, you're trying to find a missing side like this, and you know the angle and the opposed side, if you choose cosine law, you're going to have to do all this. So 2 lessons from that. 1, remember quadratic formula in case you make that choice. And I think more importantly, number 2, don't make this choice. You've got other tools. It can be done, but there are easier ways to get through it.